Another strategy we can use when solving problems in math is going to extremes. This is when we're trying to make something as big or as small as possible. In this problem, we've got 4 digits, 1, 2, 6, and 9. We're going to make two two-digit numbers. We want the product to be as large as possible. Product means we are multiplying. So let's take a look. We've got a 2-digit number times a 2-digit number. We want this to be large. Well, these 2-digit numbers have a tens place and a ones place, and tens is larger than ones, so to make it large, I got to get the big digits, the 6 and the 9, get those into the tens places. So the question then becomes, what do I do with the 1 and the 2? Well, I could do it this way, but I could put the 2 with the 9 and the 6 with the 1, and I get 2 different possibilities. So which one's larger? Well, that's a simple problem for the calculator to answer. The 91 times 62 is 5,642. 92 times 61, 5,612. So the first one is slightly larger. So just by looking at how to make this as large as possible, we've narrowed it down into just 2 possibilities, which makes it very easy for us to find the right answer quickly. Let's take a look at another example. This time we've got 6 digits, 1, 2, 3, 5, 7, and 8. We want to make 2 3-digit numbers that are as close as possible. What does that actually mean? Well, as close as possible, that means that their difference is small. In other words, when we subtract, that we're going to get a very, very small answer. So again, we're going to extremes, except this time instead of making it as large as possible, we want to make something as small as possible. Well, there's a lot of different ways to arrange those digits. So the first thing would be, well, we want to make them as close as possible. The hundreds place in each of these numbers is going to be a bigger factor than the tens or ones in determining how close they are. So we want those 2 numbers to be close together. Well, we could put a 2 and a 1. Those are pretty close together. It's not the only choice, but let's go with it and see what we can get. Now, we want to make the number starting with 2 in the 200s, we want to make that really, really small. So using the remaining digits, the smallest we could do would be to put the 3 and the 5 in the tens and the ones place. On the other hand, we want the number that starts with 1 to be as large as possible. So using the remaining digits 8 and 7, we'll put the 8 in the tens place, the 7 in the ones place. That makes that as large as possible. This gives us a difference of 48. Now, is that the best one? Well, I don't know, but we're going to have to look at some other possibilities. Keeping in mind, we don't have to start with the 1 and the 2 for our hundreds digits. We could pick something else close together, such as the 3 and the 2. Now again, we want to make this number starting with 3 as small as possible, so using the smallest possible digit for the tens is the 1. The next smallest digits remaining is the 5. Starting with 200, we want to make this as large as possible, so again, we're going to use the 87. And this gives us a difference of 28. That's closer. Can we do better? What if we started with, well, 5 and 3? I think you can see right away that because those 2 digits are not 1 apart, that this is going to get an answer that's a lot larger. It's going to be at least 100. So this is not one that's going to work for us. But we do have one other pair of digits that are only separated by 1. That's the 8 and the 7. So let's see what we get when we start with something in the 800s, something in the 700s. So making the 800 number as small as possible, we use the digits 1 and 2. And for the 7, we're going to make it as large as possible by using the 5 and the 3. This gives us a difference of 59. So that's not quite as good as what we had before. Therefore, the 28 is the best, and this is the answer we're looking for. So there you go. Going to extremes, making things as big or as small as possible, is a strategy we can use in math to solve lots of problems. Good luck with it.